coming from polymers lesson. So polymers lesson, we will be finding it in industrial chemistry. So you are learning about organic compounds, inorganic compounds, gases, and you are learning about a lot of things now. But how exactly those things are used in our day-to-day life, right? And how they are used in our industrial world, you will learn that part in this industrial chemistry. And it is actually the most interesting lesson you will find, because most of the things you are seeing there, right? And here this question is again asking about polymer. Polymer is just one industry. There are around like 13-14 industries you need to study. Okay, so let's go to the question. So it's asking thermosetting polymers. You may not know anything about polymers, but I will show you a simple single page short note. So there you have everything you need to learn regarding polymers. Okay, so we will go to that short note and let's find out where these polymers are present, and then how to get the answer. Here's the theory part regarding thermosetting and thermoplastic polymers. You know, thermoplastic means you can heat them. While heating, polymer chains will be lengthened, elongated, and when you cool them again, they will contract to the original position. That's what usually we mean by thermoplastic polymers. That means you can heat them and you can change their shape and again get the same polymer without changing any of the physical properties. But if it is a thermosetting polymer, the problem is you can heat, but after you heating, those polymer chains are going to be broken. Right? So I have written there network polymers. You can see the bonding in the network polymers. Like it's like a net, exactly, right? So when you heat them, they will try to move away relative to each other, which causing for the breaking of their bonds in the polymer chains. So then what will happen? After you cool them, they will not form their bonds again, right? So because of that, after broken the polymer bonds, right, the polymer physical properties are no longer there. Okay, basically what will happen? You can't soften them or you can't mold them by heating, and you will destroy their polymer characteristics. So then basically, if it is a thermosetting polymer, it should be a network polymer. Okay, it should be you have to just memorize this. And if it is a thermoplastic polymer, it should be a linear polymer or a branched polymer. Okay, so that's the first idea you have to understand. And then in the other side, you have examples for linear polymers and branch polymers and network polymers. So by simply examining those examples, you can understand what is the answer, right? So here we have our polystyrene, PS, polyvinyl chloride, polyethylene. So then low density, high density, whatever it is, polyethylene. So all of those are linear polymers, and I haven't included here rubber. Rubber is also a branch polymer. So then all those things will be what? Thermoplastic. You can change their shape by heating. You may have the experience of this, because when you want to like join two PVC pipes, normally when you don't have the socket, what do? You heat one end, and after expanding, then you quickly join it. After that also, still the properties of the PVC pipe is there, isn't it? It's not going to be destroyed. It's still PVC. That means you can heat and mold the PVC pipe. So that's what thermoplastic means. Right? So you can't do it for thermosetting polymers. So then you have the example for thermosetting polymer here, bakelite and urea formaldehyde. Okay, bakelite means phenol formaldehyde. So however, you need to understand about network polymers. So then you have urea formaldehyde as our answer. Let's go back to the question, and then answer is going to be urea formaldehyde. Why? Because it is a network polymer. And all other polymers mentioned here are linear or branched polymers. Okay, so they will be thermoplastic. Right, so that's the fourth question, answer 4.